Hello, Luke. Welcome to lesson 18. So today we're going to be talking about like terms. And we'll start by just doing a quick refresher of what we talked about yesterday when we talked about terms. So remember, an expression or a number is a term if there is an indicated product or if there is an indicated quotient, or if the number or variable is, we'll say, alone, all by itself. So let's see. Let's write this as term if one of these things is true. Okay, so remember, if I give you something that looks like this, okay, how many terms are in this expression? And that shouldn't be too hard to figure out. We just need to recognize that we have two indicated products here. We have an indicated product here, and we have an indicated product here. So therefore, we have one term with the sign, and then we have a second term, right? So that's just review from yesterday. We're just looking at terms, all right? Now today, well, maybe we'll do one more. So this would be an indicated product. Indicated quotient, recall, would be something like this: 3xy over maybe 2 plus x, right? So here we have an indicated quotient, which is indicated by this fraction line, and then maybe we'll have something like this after that. All right, so we have two terms here. We have an indicated quotient right here, and then we have an indicated product here, right? And if I were to add something else to the end of this, maybe we just add a z. All right, there we have a variable that's all by itself. It's all alone. That would satisfy criteria number 3 here. So therefore, this would also be a like term. So we'd have 3 like terms if we were to set something up like that. So that's just review from yesterday. Today, we're going to take that one step further, and we're going to talk about like terms. Okay? So we'll just erase this here, give ourselves some room. All right. So when we talk about like terms, we're looking for terms, first of all, that have the same variables in them. All right. So, for example, if I have a term such as xy, all right, and I'm adding that to, let's say, another term, call it xy again. Let's just use the same one. Here, this would be an example of two terms, so we should be able to spot those. This is one term, this is the second term, okay? And they are what we would call like terms, all right? They're like terms because the variables are the same. This one has an x being multiplied by the y, this one has an x being multiplied by the y. So the variables are the same, so therefore, this term is a like term with this term, okay? So pretty straightforward there. Now let's try to make this a little bit more complicated. What if we have BC plus CB? Would these two terms be like terms? Again, we have two terms. Are they like terms? And the answer is yes. So recall that this is indicated multiplication between these variables here and here. And multiplication has the cumulative property, which means we can rearrange these any way we want and still get the same answer. So instead of writing this as BC, we could write this as CB, and we're not going to change the value of that product at all. It's the way the cumulative property works. So if we switch these around and then just rewrite it, we can see that they are in fact exactly the same, just like they were in this first one. So therefore, these two terms are like terms. All right. So if I were to just throw at you some terms, what if I were to say, okay, here's a term. Well, let's go back to our block here. We'll give you a term. We'll go ACB. And then I'm going to do OBAC. And I might ask you, are these two terms like terms? Now, again, note that they are indicated products, so they can be switched around and rearranged any way we please. So if that's the case, let's just write them in alphabetical order. So if we have A, B, C, we have all the variables taken care of here. We're just rewriting them. We have the A, the B went here, and the C went here. All right, we're just flip-flopping the B and the C, just rewriting them in alphabetical order. Now here we'll rewrite them in alphabetical order too. We have an A, we have a B, and we have a C. Once they're in alphabetical order, it's very clear to see that they are in fact like terms. They are exactly the same. The variables are the same. All right. Let's try an indicated product with a coefficient, a number coefficient. So let's start with maybe 3xy. And I'll say 5xy. So the next question is, are these two like terms? Well, we might look at it and go, okay, well, let's see what we've got. We've got variables here. We've got an x and we have an x. We have a y. We have a y. They're being multiplied by each other in both. So it would appear that, okay, the x and y's match, but the 5 and the 3 do not match. So you might say, I don't think that's a like term because the 5 and the 3 are not the same. Well, in the definition of like terms, the definition is simply that the variables have to be the same and have the same processes. So we have the same processes. It's the same multiplication going on. The variables are the same. The coefficients do not have to be the same. So even though the 3 is not the same as a 5, these two are like terms. They are like terms. Why? Because the variables are the same. They both have the xy. All right? Therefore, they are like terms. So how about if I were to give you something like this? Let's go, whoops, we'll go back to the black here. What if I give you okay, so here I have two terms, okay? And I want to know if they are like terms. All right, so looking at it, let's first try to simplify them up a little bit. So we'll write them kind of in standard form, we'll call it. So in standard form, we're going to put the coefficient to the front. So we have a 2 here. We're going to put that to the front. And then we have an A, that would come first in alphabetical order. And then we have a C, and then we have a D. So in alphabetical order and with the coefficient up front, this is how we would write this first term. Now the second term, we have a 3 and we have a 4, which is interesting. So we have two numbers, but bear in mind, this is multiplication between all of these. And because multiplication is cumulative, we can multiply this 3 and 4. So let's just take those that 3 and 4 and combine them. So 3 times 4 is 12, right? 3 times 4. And then we have what left over for variables? We have an A, we have a D, or actually a C would come first, and then we have a D. So that's in standard form, all right? So now we've got both of them in standard form, and we can look at it and see if they're like terms, and in fact they are. This is a 2 with an ACD. This is a 12 with an ACD. The variables are in the same form. They're the same variables. Therefore, these two are like terms. All right? So hopefully that makes sense. Let's see here. All right. Now, let's take this one step further. And let's talk about adding like terms. Maybe we'll even write that up here. Adding like terms. And by the way, if I have something like this, 3 plus 6, would that be like terms? We have two terms. We have the 3 and we have the 6. Are they like terms? Well, yes. Why? Well, the variables. Are they the same? Well, neither of them have variables. So certainly you could say that they are the same. Therefore, they would be like terms. Okay. How would you then add it? You just add it like normal, right? So that's an easy one. But once we start talking about variables, it gets a little bit more complicated. So let's say I've got 2x plus 5x. So the first thing we need to recognize is that we have two terms. Let's point those out. We have this term and we have this term. Okay. And then we need to say, okay, are they like terms? Well, are the variables the same? The answer is yes. They both have an x. Therefore, they are like terms. Okay. And if they're like terms, we can add them. That's key here. If they're like terms, we can add them. All right. So how do we add like terms? Well, let's look at this a little bit closer. And we're going to hearken back to our last lesson when we talked about distributive property. So remember, if I have something that looks like this, we talked about this yesterday, we can distribute this x through, right? And we can get x times 3 is 3x plus x times 2, which is 2x, and that would give us this, right? So what we're going to kind of do now is undo that distributive property. So if you look at this, 2x plus 5x, they both have an x in it, all right? So in a sense, if we can kind of pull that x out, do the opposite of what we did over here. Here we ended with this expression, which had x's in it in both terms. We started with the x on the outside and just the numbers on the inside, right? So if we wanted to start from here and go back to what we had originally, you could kind of think of this as having to pull the x out, right? Since they both have x's, we're going to pull that x out, set it outside the parenthesis, and then eliminate that x and see what's left on the inside. So we pulled the x out, which left us with a 3, plus we pulled the x out of here, that leaves us with a 2, right? Which brings us right back to where we started, the x times 3 plus 2, right? So we're going to do kind of the same thing here. So think about this in terms of pulling the x out, all right? So if we pull the x out, what are we left with inside our parentheses here? We pull this x out, the x goes away, we're left with a 2, and the x has gone away here, so we end up with a plus 5, all right? So now that we've pulled this x out, let's add these parentheses. 2 plus 5 is 7, right? I still have my x out here. That's implied multiplication. So x times 7, I would write that with the coefficient first. It's just 7x, right? You following me? So we could say that 2x plus 5x is equal to 7x. All right. So all we're trying to really show here, and you don't have to think about all of this every time. All we're trying to show you is that if we have like terms, you can add them by simply adding the coefficients. All right. So add that 2 plus the 5, that gives me a 7. Make it a like term with both of these other terms. We put an x, making that a like term with these ones. So 2x plus 5x, just add the numbers, 7x. All right, does that make sense? So if I have 3y plus 2y minus 4y, what would we do here? Well, like I said, first we need to recognize that we have three terms, and we need to recognize further that they are like terms. They all are the same, the y, the y, the y, just different coefficients, which is fine. Now we can add these by just adding the coefficients. So a 3 plus a 2 is a 5. 5 minus 4 is a 1. Now we have to include the y so that everything is a like term. So the answer would be 1y, which, by the way, can be written as a y. That's an appropriate way to write 1y. The 1 is just invisible. We've talked about invisible ones before. This is another example of that. When we have a variable and there isn't a number at all in front of it, we can just assume that there is a 1 in front of it. That's the coefficient, which actually is, I know I'm getting a little sidetracked here, but just remember that, because if I were to give you some variable, let's say I gave you the variable, w, and I said, hey, Luke, what's the coefficient for the variable w? And you might say, well, I don't see a number here, so there isn't a coefficient. Well, actually, there is a coefficient. The coefficient is the invisible 1. So 1 is the coefficient of this term here. Okay, so it's a little bit of a sidetrack, but it's a good thing to note. So either one of these answers would be correct, 1y or just y. Later, we're always going to write this as y. We're not going to even bother writing the 1. So most of the time, in the future in particular, we're just going to be describing that answer as y, and that's it. All right, so let's try some of these. All right, so let's look at these problems. So we have a 3x plus 5 minus xy plus 2yx minus 5x, and we want to simplify this. And if we're going to simplify it, we need to try to essentially make everything smaller. Combine things that can be combined, multiply things that can be multiplied. Just do anything that we can within this problem. All right. So looking at it, the first step is to look at the terms. We've got multiple terms here. We have a 3x term. We have a plus 5, a minus xy, plus 2yx, and a minus 5x, right? So we have a grand total of 5 different terms in this expression. The next thing is to look for like terms. So let's take the first number here, this 3x, and we're looking at the variable. We have an x in there. So is there anything else in this expression that just has an x? Well, if we go to the next term, this one doesn't have any x. If we go to the next term, it does have an x, but it's not just an x. It's an x times a y. All right? This is just an x. So this negative xy term here would not be a like term with 3x because it has more than just an x, it has a y. All right, so we keep moving down the line. Plus 2yx, for the same reason, that cannot be a like term with 3x. And then our last one, we'll see that we have a negative 5x, which is beautiful. So that's right on. We have just an x. Remember, the coefficients can be different. All right, so we would say, great, then this and this are like terms. All right, and if I were to go ahead and add those two, we'd have a 3x plus a negative 5x. So think about that. We're going to add the coefficients, 3 plus a negative 5, or 3 minus 5, if that's easier to you. So if you add those, 3 plus a negative 5, you're going to end up with a negative 2x, right? And now let's move on. Let's go to another color here. Let's look at this one. Is there anything that's a like term with this one? Notice that it has no variable. So if we look down the line, the only things that are left over are these two. They both have variables. So no, that's a term all by itself. There is no like term with that. So that's as far as we can go with him. We can't add him to anything. So we're just going to include him as part of our answer here, plus 5 all by himself. And then we'll continue, and we'll take maybe a blue color here and go to the next term. So looking at this term, are there any like terms? And the answer, well, we've only got one term left. And notice it's a little bit tricky. This one is yx. This one is xy, so they're in a different order. But remember, that doesn't matter. We could rearrange those just as easily. So these have the same variables, so therefore they are going to be like terms. Right? So now let's look at that. So we've got a positive 2 yx minus a, now remember this is an invisible 1 in front of these because we don't have a number coefficient. So there's an invisible 1. So we have the 2yx, positive 2yx, plus a negative 1 xy, which is the equivalent of yx. So you add the coefficients. 2 plus a negative 1, or 2 minus 1, is 1, a positive 1. So we end up with a positive 1, which I'm just going to turn that 1 invisible, xy. Write it in alphabetical order. All right? And at this point, we can say, oh, we've gone through all of our terms. We've used all of our terms, so this is as far as we can go. Nothing in here is a like term with another. This is our solution. All right? So let's try another one here. So let's do this one. So again, let's look at the terms. We've got multiple ones here. We've got this term. We've got this term, and this term, and this term. Right? So let's look at whether or not we have any like terms. So 3xy. Positive 3xy, do we have anything with variables xy? So the next term, well, we do have the xy, but again, we have a z also. So therefore, it cannot be a like term with 3xy. Here we have a negative 10yx. Now, again, it's switched around, but x and y and x, there is no difference between those two. So these two are definitely like terms. And then this last one, well, we have an xy, but we also have a z, so that's not going to be a like term. So we have two terms that are alike with this 3xy, so we can add those together. So we add the coefficients. 3 plus a negative 5 is going to be a negative 7xy. Right? And then we can move on. So if we move on to the next one, we've got our positive 2xyz. And if we look over here, we have a negative 5yzx. Now, you might want to look at this closely because x, y, z are also over here. This is the same set of variables. We have x, y, z. We have x, y, and z over here. So they are the same. So therefore, they are like terms. And we can add them. So we have a positive 2 plus a negative 5, which is going to be a negative 3xyz. And we've used up all of our terms, so this is our answer. All right. Excellent. Let's go to the next one. This one, why don't you pause the video, go ahead and try this one on your own, and then we'll do it together. All right, so let's see how you did. So to begin with, we look at our terms. So maybe we'll just make it clear. We'll underline them here. We have the 4, we have the plus 7 mxy, the plus 5, we have a plus 3yxm, and we have a negative 15. So we have 5 different terms. Let's look for like terms. So we start with this one. We have a 4, so it's just a coefficient all by itself. Do we have any other coefficients all by themselves? Well, yes, we do. We've got one here. We've also got one at the end. So we can add all 3 of those together. 4 plus 5 is 9. 9 plus a negative 15 is going to be a negative 6. So we have a negative 6 for those like terms. Now let's go to our next term here. Oh, get a different color. So we have a positive 7mxy. Now over here we do have an mxy. It's just in a different order. So those two will be like terms. So if we add those together, plus 7 and a plus 3 is a plus 10. So we have a plus 10, and we'll put them in alphabetical order, mxy. And we've used up all of our terms. So that is our solution. All right. And let's try one more. Go ahead and do this one on a separate sheet, and then we will do it together here. All right, so our terms, we have a 3x, we have a negative x, a negative y, a plus 5, a negative 2y, a negative 3x, a negative 10, and a negative 8y. We've got tons of terms in here, right? What have we got? 8 different terms. So let's go ahead and sort our way through. Start at the beginning. We have a 3x. Do we have any other x variables in here? Well, sure. This one has an x. Remember, it has the invisible 1 there. It's just an x. So those two would be like terms. We have a negative y. That wouldn't work. Positive 5. Nope. Negative 2y. Nope. Negative 3x. Yes. That has just an x in there. Negative 10, nope, and negative 8y, no. So we can add these up. So we have a 3. Now remember, this has an invisible 1. So a 3 and a negative 1 would be a 2. A 2 plus a negative 3 is going to be a negative 1. So we're going to end up with a negative 1x. And again, I'm going to make that 1 invisible. So we'll just make it a negative x. And then we can go on to our next terms. So we've got a negative y. Anything else? Positive 5? Nope. Negative 2y? Yes. Negative 8y? Yes. So adding those together, we have negative 1 and a negative 2 is a negative 3. Negative 3 and negative 8 is negative 11. So we have a negative 11y. And then we've got our final set of terms here. We have our plus 5, which is a like term with negative 10. So plus 5 and a negative 10 is a negative 5. And that would be our solution. So hopefully that makes sense, Luke. They're pretty straightforward. You just need to be very careful that you catch all of the like terms as you look through the problem. So go ahead and work on today's homework sheet or our list of homework problems, and we will see you tomorrow.